The topic of this workshop is actually is it is a part of a series, and the series about exploring front-end frameworks internals. And today will be part one, um, which in which I would talk about the basic structure of front-end frameworks and the reactivity system of Vue 3. Um, this presentation will be separated into 6 parts. The first part, in the first part, I will talk about the motivation. I will answer the question why was this series born, and after that, I will talk about the basic structure of front-end frameworks. And in part 3, we will look into how Vue 3's reactivity works. And then we'll have a simple demo. And then I will conclude the presentation, and then we'll have a Q&A section. So first, I will talk about the motivation. Depending on which land you come from, if you come from Vue 3, for example, have you ever wondered why watch effect can magically rerun every time the reactive state inside it change without explicitly being told? Like, for example, in React, you have to explicitly tell use effect of its dependencies. And if you come from React, have you ever wondered why still state closures happen when using hooks? And why does the order of hooks matter? And you are forced to always use hooks at the top level of your React function. And if you have looked into Solid, have you ever wondered why it has a React-like component function, but that function actually only runs once and still manage to have the same functionalities? And what the hell is it so fast? So if you have asked yourself such questions and want to dig deeper to find the answers, you will find this series interesting. This series will first introduce the basic structure of front-end frameworks and libraries, and then tap into the internals of these libraries frameworks part by part until we can understand and build a simplified version of each library framework by ourselves. We might not be able to reach that end goal, but we'll surely learn a lot in the process. So now I will dive into the basic structure of front-end frameworks. The currently popular front-end frameworks can be divided into 2 categories: those with virtual DOM and those without. First, we'll go with the front-end libraries or frameworks that use virtual DOM. For example, there is Vue and React. The basic structure of these frameworks can be depicted is shown in the diagram that you're seeing right now. At a high level, the roles of each unit in the structure is as follows. First, you have the compiler. The templates or JSX that you write will be fed into the compiler, and then the compiler will output the render function code. And then the virtual DOM renderer or reconciler is in charge of invoking the render functions and managing the virtual DOM tree. For example, it will have to react to state changes and update the virtual DOM accordingly. React calls its component, calls the unit the reconciler, while Vue calls it the runtime renderer. React calls it the reconciler because one of its main job is to perform virtual DOM diffing or reconciliation. So uh, the two terms are interchangeable. Um, and then we have a very important unit, which is the reactivity system. This unit handles reactivity and state in each component and throughout the whole application. It is often decoupled from every other unit in this structure, which is why you can create reusable hooks without the presence of any render functions. And then we have the native renderer. Basically, this unit takes render instructions from the virtual DOM renderer or reconciler and then decides how to actually render according to its targeted environment. For example, if its target is the web, it will render and update the actual DOM. Um, when targeting the web, Vue will use a separate package, which is often abstracted away. And for React, you will have to explicitly import a package named React DOM. Um, Both frameworks or libraries allow creating a custom renderer when targeting non-DOM environments. For example, if you look at the Vue documentation, it has a it has a section about custom renderer API. So basically, when you target non-DOM environments, for example, if you're building mobile applications, you will need to create a custom renderer, and Vue allows that. And the same goes for React. It has a separate package called React Reconciler, and basically, if you have already heard about React Native, um, it uses this React reconciler to build a native renderer. Okay, um, let's continue. So we have talked about the basic structure of the front-end frameworks with virtual DOM. Um, and how about the ones without virtual DOM, the ones that don't use virtual DOM at all? Um, basically, the structure is much more simple. You just simply remove the virtual DOM renderer, and you just have the native renderer. Um, there's a few points worth noting here. The first point is that you shouldn't let the directions of the arrows fool you, because looking at the diagram above, you might think that the reactivity unit needs to directly call the renderer, and the renderer somehow needs to know about the methods of the reactivity system. But that's not how reactivity works, and we'll continue to explore and understand this matter later in the series. Well, in fact, you can completely replace the reactivity system with another without changing the renderer and vice versa. For example, um, this is a simple library which uses mobx as a reactivity system together with the DOM renderer of solid. And for example, we have we have this small library here, which uses Vue's reactivity system with the DOM renderer of solid. If you look into the package.json here, you can see that it actually uses the Vue reactivity package as one of its dependencies. And the surprising fact about this is both of the libraries I have just shown you perform much better than their original usage. For example, if you look into Vue, you can see that it is way over here. But the package which uses only the Vue reactivity system and coupled with the DOM renderer of solid, the performance is way better. Here's the mobx.js library. You can see that if you pair mobx with React, it will result in a horrendous performance. So so yeah, my point here is that the reactivity system and the native renderer can be completely decoupled from each other. They don't need to know about each other. And the last point that I want to point out is this is a very simplified structure. For instance, we haven't taken into account the scheduler, which is a very important part of these front-end frameworks. And later in the series, when we have discussed the motivation behind a scheduler, we'll have an updated diagram which also includes the scheduler. So now that we have explored the basic structure of front-end frameworks, we'll proceed to explore each of the units inside the structure for each library framework. My plan is to explore those aforementioned units in Vue 3, as it is currently the framework that I'm using extensively for my projects. Though I have also used React and Solid as well to a large degree, and I do plan to include them in this series. So, in this first part of the series, we'll look into how Vue 3's reactivity works. And within the scope of this presentation, we'll only explore ref and watch effect for now. The other reactivity functions will be explored in the next part of the series. So we're talking about reactivity a lot here. What is it really? It's actually not a new paradigm. The typical example is an Excel spreadsheet. In the example shown here, cell B1 is defined as equal A1 plus A2. When you update A1 or A2, B1 will also reactively update. So the point here is the value of a cell always reacts, and basically this is what reactivity is about. However, in JavaScript, variables don't work that way. If you define A1 and A2, and then you define B1 is the sum of A1 and A2, and then you change the value of, for example, A1, and you log the current value of B1, it will still be the same. So JavaScript does not work that way. So if our purpose is only to log the sum of A1 and A2 when either A1 or A2 changes, we can write something like this in Vue 3. So basically, you use ref and watch effect, and then in that watch effect, you can log the sum of A1 and A2, and each time A1 or A2 changes, it will log the updated value of their sum. But the point here is, how does it work? How does watch effect magically know when A1 or A2 changes? To answer this question, let's build ref from scratch. It begins with an object with only one property, which is value, with this getter and setter. Nothing happens here yet. The magic trick we're going to use here is when the value property of the ref object is red, or when the getter method is called, we will automatically add the caller. We will add the caller as the subscriber of the ref object. And we will also call this subscriber an effect. Effect is short for side effect. And the ref object now becomes a dependency of that effect. So as you can see here, in the getter method, you will have you will call a function to add the current caller or the active effect to the list of the subscribers of the ref object. You can see here there is a public dep. This is actually called, if you understand it, then it's actually public subscribers. It's here I'm just mimicking the way that the Vue's code base names the variable. So yeah, as you can see here, when the value of the ref object is red, or when the basically when the getter function is invoked, it will add the active effect to the set, to the array. We can call it an array, but it actually has to be a set because we don't want duplication. So yeah, it will, the active effect will be added to the set, the dependency set of the ref object. So there is the first problem. We don't know what we don't know where does the value of active effect comes from. In other words, how do we know which effect is currently running? And the second problem here is we need to trigger and inform all of a ref object subscribers or dependencies when its value property changes. Let's deal with the second problem first because it's quite straightforward. As you can see here, I have added a new method that will be a new function that will be invoked when the setter method is called. Basically, it will iterate through the dependency array of the ref object, and then it will call, it will invoke that subscriber or effect. So now we have the most important question left, which is where does the value of active effect come from? So to answer that question, let's take a look at the rawest implementation of watch effect. Here we will export a variable called watch active effect, and then we will define the watch effect function. The watch effect function basically takes in a callback. We call it the effect handler. As you can see below here, because the watch effect is always triggered immediately, we'll trigger that effect function. And inside that effect function, before we trigger the handler, we will set the active effect to the current effect. And then we invoke the effect handler. And after we're done, we will set the active effect to undefined. So the magic trick is the magic trick happens when you call the effect handler, because the effect handler, it will always when you call it, it will read the value property of any ref object inside it, which basically trigger the getter method of the value property, and which in turn will add this effect as one of the subscribers of that ref object. So as you can see here, it's basically effect handler, and then we have the value getter method will be invoked, and it will call the track ref value function. And then the track ref value function will add the active effect, which is already defined here as the current effect. So yeah, that's how watch effect knows exactly when to rerun the effect when the value of the ref object inside it changes. So let's see the code in action. Yeah, basically this is the part of the code that I have already shown you. This is the ref object. And then we have the definition of the watch effect function. We will export the active effect variable here, and then we will import it here. And then we have A1 is a ref object, and A2 is also a ref object. And we have the first watch effect, which is its job is basically to update the DOM according to the value of the current values of A1 and A2. And in the HTML, we have defined 3 diff with 3 different IDs to represent the value of A1, A2, and B1. Yeah, so the watch effect will update the A1 and A2 diff, and then the second effect is to watch the sum of A1 and A2 and update the B1 diff. And then finally, we have a set interval which updates the value of A1 and A2 every second. And then, yeah, you have the running code here. So basically, it's a very simple reproduction of the actual implementations of ref and watch effect. I need to have a few fair warnings about the implementations that I have just introduced. That it is still nowhere near usable, and we have left out too many cases where it might fail, and we also don't have any kind of batching. For that, we will need a schedule, and the flow of control is a little bit messed up. For example, in the code here, what I mean by the flow of control is messed up is that inside the ref file, we actually import from the runtime call the active effect. So it should not really be this way, but for the purpose of simplicity, we'll just leave it this way, and we'll continue to refactor this later in the series. By the way, I still think that it can still serve at its purpose as an oversimplified example of what's happening behind the scenes. About the conclusion and future plans. So over the course of this presentation, I have introduced the basic structure of front-end frameworks and libraries, and tapped into the two reactivity functions of Vue 3, which is ref and watch effect. And in the next part, my plan will be to introduce more reactivity functions of Vue 3, and we will also refactor the current implementations of ref and watch effect. And hopefully that will be part 2 will be enough for the whole reactivity system of Vue 3. And then in part 3, I will move on to the rendering mechanism of Vue 3. So yeah, that's the end of my presentation. And now if you have any questions, this is the time. By the way, I have an article here that we need. If you can spare some time, you can go and check it out and leave some reactions to it. Okay, now it is the Q&A section. Do you guys have any questions?
Actually, I saw the guy and I saw that it look like same with the view number 2 reactivity system, right? Because currently I know that in the view number 3 they're using something like a proxy or something like this to building the reactivity system in view number 3. So
Actually, for let me show you the slide of ref. Yes, what you're talking is partially correct, but there's a catch. In Vue 3, everything is based on the getter setter methods. So basically, when you define like a data in Vue 3, yeah, for example, if you define this data factory, it will return an object. And what Vue 2 does is that it will take this object and it will augment it with every property inside that object with a getter and a setter method. And the downside of that approach is that when you add a new property to that object, it will not work because Vue 2 only add the setter and getter methods to that object at the initialization phase. It does not dynamically track the object and then add getter and setter methods to any newly added properties. So now what you're talking about is proxy is there a solution to that problem, but they only use the problem with proxy is that it can only be used with object. It cannot be used with primitive values. So we have uh, the reactivity function for that. Like you have to import a reactive from view, and that reactive function will only work with object, and it will use proxy. And ref is for another purpose, because with reactive you can only use object. You cannot really define a primitive value. So Vue 3 also introduces ref to hold only primitive values. Basically, you can also define object inside ref, but the ref is specifically for primitive values. And because of that, because of the fact that proxy doesn't allow primitive values, um, you still need to use ref. And ref, like I have explained here, it still use getter and setter function.
Oh yeah, it so
Is
means
that
that we've been using reactivity. I mean, the reactivity support function for declare. I mean, implement the object. I mean, right. It so means that we've been using ref for private value, and we've been using reactivity for object value, right?
yes, that's basically the intended purpose of those two functions. Ref will be used for primitive values, though no one forbids you from using it for objects.
Yes.
And reactive is specifically meant for objects.
Yes. Okay. Thank you.
We will talk about proxy and reactive in the reactive function in the next part of the series, and it will explain a lot more of your concerns.
Yes. Yes. Okay. Thank you. I have no question for now. Thank you.
Okay. Does anyone else have any question? You don't need to ask a question to be able to speak. You can just share your thoughts. Like, because basically we are in the middle of a discussion, not it's a workshop, not like a formal presentation. So you're free to speak your minds. Okay, Khano. If you guys have you can continue to ask questions. If you guys have no questions, then I will have some questions for you. Like for example, is what I have introduced to you in this presentation something new, or something you haven't known beforehand? Or is it something that you have already known and for example, this the basic structure of front-end frameworks. This is not actually from a creditable sources or anything. I just made it up from my own experience in. So yes, this is basically what I personally made up, not from a creditable source. Oh, Khaled, yeah, I can understand that. This is the first time that you learn about the structure because I just made it up. But I think this is quite close to actually quite close to what actually happens um, inside these frameworks. So, Khaled, what you imply here is that you already know about how the Vue 3's reactivity system works under the hood, right?
S- Hello. So I have a questions for you about the code.
Okay.
Because uh, yeah, I see the how the code works, but I want to know this code based on the real structures of Vue 3 are just a simulation function that you that you create.
Yes, as I said in the beginning of the presentation, the ultimate goal of this series is to rebuild each of these frameworks libraries from scratch, and we will imitate the original implementations as closely as possible. So as you can see here, I have already structured the uh, the folders according to the actual code base of Vue. For example, I will show you right now the code base of Vue. Here, for example, you have the reactivity um, modules and the runtime call modules. And basically, what I'm doing here is trying to mimic that. Though this is in the first part, this is still a very oversimplified version of it, but we'll gradually come closer to the original structure. Uh, what I'm doing here, even the names of the methods, even the way they are named, the way they are structured, the way they are ordered and organized, it all imitates the original implementations of Vue. For example, if you look at the ref source code of Vue, yeah, you can see that there is a track ref value function that I've just introduced, and the track ref value, a trigger ref value function, and track ref value functions. And then you have the ref implementation class, which is basically just this. Of course, we haven't covered edge cases, so our code looks much more simple. Yeah. Does that answer your question?
Yeah, it's okay. It's okay. Yeah.
Correct. You said why React is several name from React.js because we will we will discover this later in the series. But yeah, React isn't truly reactive. unlike the reactivity system of Vue, for example, React, for example, use state and use effect doesn't work that way at all. That is why in the JS framework benchmark, you can see that they have mixed mob X with another renderer. They have mixed the Vue 3 reactivity system with another renderer and many things else. They have mixed a lot of things together, but there hasn't a single library that mixes React with something else, because React simply doesn't allow that, because its reactivity system cannot be truly called a reactivity system. So React is a bad name for React.js. Okay, so Hein's questions is about the pros and cons of having the virtual DOM. Actually, Svelte, since the birth of the new version of Svelte, the author of Svelte has like kind of made a propaganda saying that the virtual DOM is pure overhead, and actually you can still see that in their official page. Like they promote no virtual DOM as like an advantage, and something and virtual DOM is something like a really bad thing and pure overhead, but it might not be the case, because if you see the virtual DOM isn't the one at fault. It's actually much more complex than that. But I'm sure that the virtual DOM implementation and their related implementation in React are just bad. But for example, if you look into a framework that closely resembles React, and it also uses virtual DOM, you can see that its performance is even better than Svelte. Like Svelte is way over here, and yeah. So the virtual DOM is not inherently good or bad. It depends on a lot of cases. And yes, this is a very interesting question, and I think I will address it in one of the articles in the series. Yeah, exactly. I deserve another workshop. So I can safely assume that everything I've introduced in this workshop is something new to you guys, and hopefully you guys have got something from it. Okay, thank you, and please don't forget to go to the article and react to it. Uh, it will be kind of helpful. Oh, hello, Fabian and Alexander. Um, since when did you come? Like, I'm not sure if you have heard the entirety of this presentation or just mm, a part of it. Oh yeah, yeah. You missed the first 8 minutes of the presentation. Okay, so the first 8 minutes is about the basic structure. Okay, I think you can read that in the article and yeah. Okay, okay. So thank you for your time, and hopefully I will spring up another workshop, the part two of this series in the near future, maybe even next month. Um, and I will inform you guys again if you're interested. Okay. Why did why did you not just say too bad? Well, you don't have to be at Linagora to attend the workshop. Actually, this workshop is open to the public, and literally anyone can join, and so you don't have to worry. Okay, so this marks the end, the real end of the workshop. You are free to leave now, and yeah, thanks again.